Hassler here. I'm going to walk you through the 7-5 lesson. Today we looked at the quadratic function f of x equals parentheses x minus 4 times parentheses x plus 2. And question 1 says, explain how you know that f is quadratic. Other than the fact that I said we're looking at a quadratic function, one of the things that we talked about that qualifies you to be a quadratic function is if you end up with an x squared. And so if I multiply these x's together, I do get x squared. If we do our box method or our break apart method, we actually end up with x squared plus 2x minus 4x minus 8. And if I combine like terms, which we could do, I would get that minus 2x in the middle. But because I have an x squared term, that verifies that I have a quadratic. The other thing we said is that it's a product of two lines or two linear factors. Back when we started Unit 7, we had said three things could make you a quadratic function. Either that the biggest exponent is 2, that I'm multiplying two lines together. And so if I were to think about this as being in y equals mx plus b and y equals mx plus b, I have two lines. Or that the second difference is constant. Well, I don't have a table here to look and determine whether the second difference is constant. And so either of these two answers would be an appropriate answer. 2 says find f of 0. F of 0 means I'm going to replace these two x values with 0. So f of 0 equals 0 minus 4 in parentheses and then 0 plus 2 in parentheses. And if I calculate that, I get negative 8. And so I really have 0 comma negative 8. And this would be our y-intercept. I'm looking for when x is 0. 3a says find f of 4 and f of negative 2. So again, I'm just going to take this equation and I'm going to replace the x with 4 the first round. 4 minus 4 times 4 plus 2. And if I calculate that, I'm going to get 0 because that 4 minus 4. And then f of negative 2. So again, I'm going to replace my x's with negative 2. And because negative 2 plus 2 is 0, my calculation is 0. And what do these values tell you about the graph? Well, these are now the points 4, 0. Put 4 in, got 0 out. Negative 2, 0. And these are the x-intercepts of the graph. That's where I cross the x-axis. 4 says, what is the axis of symmetry and how do you know? Well, when we talked in the last section about axis of symmetry, we talked about making that number line. And in this particular case, I know that my x-intercepts are at negative 2 and 4. And my job is to try to figure out what that middle number is. So there's two ways that I could do that. I could either figure out what the distance is between these numbers. That distance is 6. Cut that in half because I'm trying to find the halfway mark between these two. So that's 3. And what that means is that this negative 2 is 3 units away from the axis of symmetry. 4 is also 3 units away from the axis of symmetry. And so either negative 2 plus 3 because I'm headed to the right, or 4 minus 3 because I'm headed to the left. And so that would make my axis of symmetry at 1. But we talked about another way to do this. And the other way is that I could average the x-intercepts. I could find the middle value by averaging. And averaging means I'm going to add up my two numbers. And I'm going to divide by 2 because I'm adding two numbers. And when I do that, I get 2 over 2, which is 1, and that matches. So there's two approaches to finding the axis of symmetry if I know those x-intercepts. 5 says find the vertex of f. And remember that the axis of symmetry is the x of that vertex. So first of all, a vertex is an ordered pair, x comma y. And the x is the axis of symmetry, okay, for the vertex. Those two things match up. And so if I know what the x is, we found that to be 1 in the last problem, then what I can do is the same thing that I actually did in problem 3a and problem 2. I can evaluate my function using that exact x value. In other words, I can substitute my known x value into my equation and I can calculate, right? I would get -3 times 3, which gives me 9. And so my vertex is this ordered pair 1, 9. And it says, is this vertex a maximum or a minimum? Well, let's think about it. Actually, before we answer that question, let's go down here and create a table and plot some points. Then we can go back and answer that question of whether we have a max or min. So it says, use your work from above to complete a table of values for f of x and then create a graph on the grid. We can check this on Desmos, which we will. I have some ordered pairs that we have already determined, right? I have this ordered pair of 0, -8. I have these ordered pairs of 4, 0, -2, 0. I have this the vertex. And so I'm going to start filling out my table. -2 was the smallest x value we had, and the output we knew was 0. So I'm going to fill in what I know here. And I only know some of these outputs, right? Like -2, 0, I knew 4, 0. Let's see, I didn't know -1, but 0 was -8. 1 was, oh, my bad. This is -9. I apologize. Go back up and fix that vertex. -3 times 3 is -9. Goodness. -9. And now I can plot these points that I know. I know -2, 0 is the x-intercept. 0, -8 is the y-intercept. 1, -9, that makes sense, is the vertex. 4, 0. Okay. If I draw in that axis of symmetry, I can plot one more guaranteed point, right? If the y-intercept is 1 away on the left of the axis of symmetry, I can plot a point 1 away on the right, and I can go ahead and connect that. It says, is the vertex a maximum or minimum? So it's a minimum. It is the lowest point on my parabola. And again, I want to go and I want to graph this on Desmos. So on Desmos, on your graphing template here, I'm going to move this over. There we go. I can type in that original function that we had. We had y equals parentheses x minus 4 times x plus 2. And I want to check if this matches my graph on my paper, and it does. And so Desmos is going to be a super powerful tool for us to use so that we can check our answers, verify answers that we have. We don't want to use Desmos to get all of our answers. We want to be able to find some things algebraically, but Desmos is a great tool to use as a check. Okay, so let's go to the backside and see what we have here. It says the graph of the function x minus 4 times x plus 2 is shown to the right. This is the same function that we had on the other page. I'm just going to box this off. This is what we've already typed into Desmos. This is the picture we've already graphed. I just went ahead and regraphed it here for you. It says describe how the graph of f of x has been transformed compared to the parent function, y equals x squared. So recall that the parent function had a vertex at 0, 0. See, I'm just going to draw that in, 0, 0. And now I have to describe how this new graph has changed compared to that parent function. In other words, where's the location of my new vertex? Well, to go from 0, 0 to my new vertex, I had to go to the right 1. So I'm going to describe that we went to the right 1. And then I had to go down 9. Down 9. So now it says in B, write an equation in the form y equals x minus h squared plus k for the graph based on the transformations. We've actually did this in the last section, the 7.1 to 7.3. Y equals, well, if I go to the right one, I have to say x minus 1 and then squared. And if I go down 9, I actually have to write minus 9. Now, here's what I want to do. I want to take this equation that we just wrote, and I want to type that one into Desmos with the one we already have. And these two things should be the same, because all I'm doing is describing this new graph that we have by using a different form of an equation. So let's go to Desmos and let's add another one in. And so let's see, we've got y equals parentheses. We said x minus 1, opposite of what you think would happen, and parentheses squared, and then minus 9. And it turns out that that blue graph is the same as that red graph. And if I click to turn that blue graph off, you can see that it's the same as that red graph. That's really great news, because what that means is that I wrote an equation that gives me the same graph. Let's see what Sasha says. She says the f of x can also be written as f of x equals x squared minus 2x minus 8. Do you agree? Well, let's see. I'm going to take this f of x. I'm going to rewrite it. F of x equals x minus 4 times x plus 2. And I'm going to multiply this out. I know how to do that now. So if I do my box method or my break apart method, I like the break apart method, where each term in the first group is going to be multiplied to each term in the second group. I end up with an x squared plus 2x minus 4x minus 8. And so x squared minus 2x minus 8. Hey, that matches. But what I want to do is show you how Desmos can also confirm that. Again, algebra is the first approach, but Desmos is a great way to check. So let's jump over to Desmos. We're going to keep these other two equations written. We're going to go ahead and write Sasha's equation. Y equals, we have x squared minus 2x minus 8. And lo and behold, that green graph is the same as the blue graph, which was the same as the red graph. Okay. And so again, Desmos is a great way to check. 10 says, find f of 0 using Sasha's equation. Okay, so this is Sasha's equation. F of 0 just means that I'm going to replace my x's with 0. And when I do that, I'm just left with negative 8. And that matches my y-intercept that we had already found on the previous page. Okay, so we have 3 different equations boxed off in red. We're going to talk about all those different forms, the fact that they give us the same graph, and we're going to talk about ways of finding special points of a parabola. Okay, so the first thing that we're going to do is we are going to break this up into 3 parts. We're going to say vertex form, and we're going, actually, I don't want to go all the way down, just part way down. Okay. And then we are going to say intercept form. And then we are going to say standard form. All right, so vertex form is this form y equals a parentheses x minus h squared plus k, where my vertex is hk. Now, remember that the h tells us if we move left or right, opposite of the sign that you see, and the k tells us if we move up or down, exactly associated with the sign that we see. Now, intercept form looks like this. Y equals x minus p times x minus r. And that just means that this is going to be called factored form. And we're going to talk more factored form. That doesn't look like you can even read what that says. Let's try that again. Factor, F-A-C-T-O-R, factored form. Because this is written as 2 items being multiplied. They're factors. And we're going to talk a lot more about that form in Unit 7.6. So we don't want to say too much about that right now. But it is the product of 2 lines. This is what we started out with today. So we have the product of 2 lines. I'm multiplying 2 lines together, which is going to give me that x squared. Finally, I have standard form, which is y equals ax squared plus bx plus c. And standard form gives me a couple pieces of information. Standard form gives me the y-intercept easily. We can say the y-intercept is always that C value, okay? And we can get the axis of symmetry. And we're going to use a special formula to get that axis of symmetry. It's called x equals negative b over 2a, where I'm going to use the coefficient of x as my a value and the coefficient of b as my, the coefficient of x squared as the a value, the coefficient of x as the b value. Now, we haven't really done a whole lot with that special formula, and so I just want to give you an example. The example I give you is y equals 2x squared minus 4x minus 5. Okay, and so I could say if I want to find the y-intercept, I would replace each of my x's with 0, because a y-intercept always has an x value of 0. And you are left with that c value. So I'm just going to box off, this is my c value. And notice that my y-intercept is that c value, 0, negative 5. Okay. The other thing is if I want to find the axis of symmetry or the vertex, we're going to do both of those. I'm going to say AOS for axis of symmetry. Is this x equals negative b, I'm going to put parentheses, over 2a, I'm going to put parentheses, which means I need to know what the b and the a are. And so again, the a is the coefficient of the x squared. I'm going to come over to my equation and say a is 2. There's no x squared with this, just the number. And b is the coefficient of x, so negative 4. No x with that. And so what I'm going to do is I'm going to take that b value and I'm going to put it in this little formula. Negative 4 is my b value over 2 times 2. That's my a value. And I'm going to calculate this. Negative 4 is positive 4. 2 times 2 is 4. And 4 divided by 4 is 1. What that tells me is the axis of symmetry is x equals 1, but it also tells me what the x of the vertex is. And that's actually what I want. I want the vertex. So if I know the x of the vertex, I can just replace each x in my equation with 1, so I can figure out the y value that goes with it. So 1 is the x value of my vertex. I'm going to replace each x value in that equation with 1, and I'm going to calculate. And when I do that, I get negative 7. And so negative 7 is the y of my vertex. Now, I would only do this axis of symmetry formula if I have standard form. But if I'm asked for the vertex or axis of symmetry and I have vertex form, I don't have to do all that work I just did. I can pick that vertex out from the equation that's given. I just want to make that clear by actually working on part 1 here with you, okay? Part 1 says all 3 functions have the same graph. If I graphed any of these 3 in Desmos, they would all look the same. It says, what is the vertex of the graph? Well, and it says, which equation did you use to answer this question? Remember, this is called intercept form. I'm going to label that. And this is called vertex form. Hey, I'm looking for the vertex. I might want to use equation B. This over here is called standard form. Not going to easily give me the vertex. Although I could use standard form and do what we did up here to get the axis of symmetry and vertex. But why would I work that hard when I can pick the vertex out of this form here? Minus 3 in parentheses means I moved right 3. So my vertex is going to have an x value of positive 3. And minus 16 on the outside means I moved down 16. So now I have a y value of negative 16. So I want to use the form that is going to be the most efficient for me. I don't want to have to do more work if I don't have to, okay? All right, your job is to work through the problems and then check your understanding and ask me questions that you have.